In this lecture, we are going to discuss about operators in Java. So many times you will be required to do specific operations like comparing two objects or adding two values together. That's why I would consider this being an essential topic in order for us to progress further. As you can see here at the beginning of the program, I have defined two integers, one is 5 and one is 6. These values are actually random. So let's begin discussing the first operators category, which is the arithmetic operators. First off, let's clarify what's with this strange syntax here. This keyword will be outputted as such in the console, and this plus sign here doesn't interfere with what we have in the parentheses. It will just link the result of this operation to this keyword right here. So in the console, we will see something like addition, column, space, and after that, the result, which is the result of this addition. I won't discuss too much about the first four operations, which are pretty basic: addition, subtraction, multiplication, and division. Let's jump straight to the fifth operation here, which is the modulo operation. This is basically division, but instead of the result of the division, you will get the remainder of the division. If the remainder is 0, then the 0 value will be returned. Then we have these four operations here: plus increment, decrement, pre-increment, and pre-decrement. You can see that those are noted a bit differently. So for post-increment and decrement, you have the symbol at the end after the name of the variable, and for pre, you have the symbols at the beginning. Post-increment means that the value is incremented by 1 after it is evaluated in this expression. So after this line is executed, 1 will be added to 5 in our case, because the left integer variable is equal to 5. This is also available for decrement as well. So 1 would be subtracted from the value of right, which is equal to 6. However, for pre-increment and decrement, the variable is incremented before it's evaluated in the expression. So in our case, it will be evaluated before this line is executed. Let's jump to the comparison operators. Instead of a numerical value, a true or false value is returned by each operator here. So if the left is indeed less than the right variable here, true will be outputted. If not, false will be returned. There is a special case with equals here. Just keep in mind that if you want to check if two values are equal, you just need to specify two equal symbols here, not one. Because if we would have had one equal operator, then it means that the left variable, which is 5, will be deleted, and the new value for this variable will be equal to the value of the right operand, which is 6. So just don't do this and avoid these confusions. Moving back to comparison operators, we can also specify if the value is greater or equal than another value or less than equal. So we have this symbol that we can use over here for the logical operators. For the logical operators, basically there is the AND operator, which is defined as 2 ampersands. So basically, if these two statements that we have in parentheses on the left and on the right of the symbol are true, then true will be outputted. If one of them is false, then false will be returned. We also have OR logical operator, and the symbol consists of these two pipes like we see here. If one of the statements right here is true, then true will be outputted. If one of them is false, then we will get false in the console. The NOT operator will check if those values are different, and it will return true if that's the case. If not, it will return false in the console. Also, we have the assignment operator. So like I said, if you want to assign a value to a variable, then you have to use a single equal, not a double equal, which is equivalent for the comparison operator. Also, you can add specific numbers to your variable. So in this case, we just add 9 to the current value of left, which is 5. Therefore, the output will be equal to 14. And we can also subtract a specific number from our variable by specifying minus and the equal sign like we see here. We also have a special category that is not that often used in Java, which is the Bitwise Operators category. For this, we have to convert our decimal values into binary. In this case, 9 is equal to this number over here and 8 is equal to this number here. Let's delve into each operator. So bitwise AND will basically compare each bit from both numbers position by position. And whenever we have one bit on the same position on both numbers, then that one bit will be returned. If we have, like in this case, on the last position, 1 and 0, then the 0 bit will be returned. So in both positions, there needs to be a 1 bit to have 1 returned to us. So you can see that the operator here is just a single ampersand, not a double ampersand, which we've seen here at logical operators category. So just be careful not to confuse those two because they are doing totally different things. The comparison one is outputting true or false values, whereas this one, the bitwise operator, is outputting a number. So the result for this bitwise AND operation will be equal to this one because we have only the one common bit in only one position. The bitwise OR will check if there is 1 in any of these numbers in a particular position. As you can see, the bitwise OR operator is noted as a single pipe. The resulting number of this operation in our case will be equal to this one that I'm highlighting on the screen, due to the fact that those are the bits that are different in these two numbers. So if we convert this binary number to decimal, we will get 9 as the value of the left integer. We also have an exclusive OR, and this will return 1 bit only if we have a 1 bit in one of the numbers. The result after this operation will be the one that I'm highlighting on the screen. The bitwise complement operation will switch the 0-0 pairs of bits into ones and vice versa. Also, if you have a single 1 bit on a position and on the other number you have a 0 bit on the same position, you will also get a 0. So the resulting number is this, which is equal to -10 if we convert it to decimal system. Also, something to notice is that if you have on the leftmost position a 1 bit, then this is something that will transform your number in decimal into a negative number. Also, the bitwise shift will shift the number that you have on the left operand with the number of positions on the right operand. If we would have had 2 here instead of 1, then the number would look like this. This is the same with the right shift, but the shift is done in the opposite direction. So you can see that the shift with 1 for the right number will output this binary representation. And finally, the right 0 field will fill out the number with 0 bits, so the result will be equal to 0. Let's run the whole program here and let's see the results. So as we expected, the addition, subtraction, multiplication are correct. The modulo is 5 because the remainder between these two is 5. For post increment and decrement, we can see that same number, but actually after this line over here, the value will be equal to 6 in the case of the first integer, and this value here will be equal to 5 immediately after this line is executed. And you can see that the pre-increment and pre-decrement will execute everything before the expression is evaluated. The comparison operators are returning either true or false, as well as the logical operators. And also the bitwise operators are splitting the decimal representation of the bits that each and every operation here is returning. I know the bitwise operators can be pretty cumbersome, but like I said, those are not that often used. So you don't have to concentrate on these. But the other ones are pretty important because you will use them in day-to-day operations that you'll have to do using Java programming language. That's it for this lecture. Join me in the next one where we are going to discuss about if statements.